the last one that I wanted to look at is what if you have, what if you're looking at the actuarial present value of an insurance on a joint status and both of your lives have constant forces of mortality. That simplifies down into something nice as well. So we're looking at the actuarial present value of an insurance on a joint life status payable at the moment of death. So this insurance pays a benefit here of 1 at the moment of death of whoever dies first, X or Y. So this is sort of similar to what we had before for just a whole life insurance on X. It's going to be, whereas before we had, for a whole life insurance, we had, you know, if you survive to some point T and then die in that next moment, your benefit is discounted back T periods. Well, now we have two possibilities. Either this is paying when X dies, if X dies first, or at the death of Y, if Y dies first. So we either have they both survive and then X dies in that next moment, or they both survive and then Y dies in that next moment. And hopefully you can see that this makes X the first death, right? They both survive and then X dies. And this makes Y the first death. They both survive and then Y dies. So you have those two possibilities. And they would both be discounted back for T periods of interest. Whichever one happens. Okay, so you're adding up all of those possibilities, the products of all those possibilities and their associated probabilities, and you're integrating from 0 to infinity, all the possible values of T, all the possible future lifetimes, with respect to T. Okay, so I'm going to pull out the V to the T and the TPX, TPY, which we could rewrite as TPXY. And then I have times mu, I'm just going to write mu x, mu sub x, and mu sub y. It looks a little bit simpler. Okay, and then if we have a constant force of mortality, this is e to the negative delta t. TPX is e to the negative mu sub x t. TPY is e to the negative mu sub yt. Actually, I'm going to go ahead and pull out this mu x plus mu y as a constant. That's just a number. I'm going to pull that out in front of the integral. We're integrating with respect to t. Okay. So this is, of course, then e to the negative quantity delta plus mu x plus mu y. When I integrate that, get e to the negative delta plus mu x plus mu y. This is all just a constant. When be constant. So that becomes e to the negative, e to a constant over the constant. Okay, and that's being evaluated from 0 to infinity. I'm going to pull out this 1 over negative quantity delta plus mu x plus mu y. done. Okay, and then I'm left with e to the negative quantity delta plus mu x plus mu y. Oh man, this is a t here. I always forget that. This is a t. I forgot to carry the t down. This is a t. Evaluated from 0 to infinity. Okay, now e to the negative infinity is 0, and e to the negative 0 is 1. So we have 0 minus 1, should be looking pretty similar to when we did the whole life insurance for a single life. We have this times 0 minus 1, which is this times negative 1. So this negative cancels, and we're left with this. So if you saw me use this in another video and you didn't understand why, that is why it works. I hope that that helps you. I hope that that helps you be convinced that it is true. Happy studying.